All right, this is 2.2 part 3, finishing off the 2.2 notes. So remember yesterday we did look at slope, so just a reminder about that. M equals y2 minus y1 over x2 minus x1. And today we're going to look at writing linear equations. So there are three different forms that you can write a linear equation in. We've got point slope form, which is the y minus y1 equals m times x minus x1. The reason that's called point slope form is because you can see a point, x1, y1, and the slope just by looking at the equation. So m is the slope, and x1, y1 is a point on the line. Any point on the line. Slope-intercept form, that's your y equals mx plus b, where m again is the slope, and b is the y-intercept. Again, obviously named because you can see the slope and the y-intercept just by looking at the equation. And then finally we have standard form. Standard form is ax plus by equals c, where a, b, and c are whole numbers. Or you could say integers. And a is positive. So that form is mostly just, hey, let's write this in the prettiest, simplest form possible, where we're not going to have any fractions because a, b, and c have to be whole numbers. And then also a is going to be a positive number, so we can't have a negative in the front. All right, so those are our three different forms we're going to work with. Okay, let's look at the first problem. Write the equation of the line with the given characteristics. It needs to go through 3, -5, and have a slope of -2. And we're going to write this one in slope-intercept form. Okay, so the point that it's going through, that's always going to be your x1, y1. And then your slope is -2, so m equals -2. We're always going to start out with point slope form. You can do this another way, but I am always going to start out with point slope form. So I will have y minus y1, which is y plus 5, equals m, which is -2, times x minus 3. Okay, so I use that first form right here, and I just replaced x1 and y1 with my values and replaced the slope with -2. Okay, so now I want to change this into slope-intercept form, which is y equals mx plus b. So to do that, I'm going to distribute the -2. And then subtract the 5 to the other side. Nice and easy. There you go. There it is, y equals mx plus b. So your slope is -2 and your y-intercept is 1. So you should be able to picture that if you were to graph this, your y-intercept would be at 1. So we'll pretend that's 1. And your slope's going to be -2, so you would go down 2 and over 1 to get to your next point. And it would look something like that. All right, number 16, going through 3, 3, and -5, -1. And we want to write this one in standard form. So this is going to be your x1, y1, and we have another point, so we'll call that x2, y2. Now when you're given 2 points, and you don't have the slope, you're going to have to use those 2 points to first find the slope. So m equals And we'll do y2 minus y1 over x2 minus x1. So negative 1 minus 3 over negative 5 minus 3. Okay, so negative 4 over negative 8, which is 1/2. So your slope here is 1/2. And now we're ready to plug it into point slope form. Y minus y1, you can choose either point. I'll choose this one. It does not matter. You'll get the same thing either way. So y minus 3 equals 1/2 times x minus 3. Okay, now we want to change this to standard form, which remember is ax plus by equals c. So first I'll distribute the 1/2. Now I'm going to move this term with the x to the other side because, ooh, what just happened? Because it does have to be the first term in the equation. So minus 1/2 x. And I'm also going to add the 3 to the other side. Alright, so that gives me negative 1/2 x plus y equals 3/2. Okay, because that's negative 1.5 plus 3, which is 1.5, or 3/2. I want to leave that written as a fraction. Okay, so now we have our terms in the correct order. We have ax plus by equals c, but now remember we can't have any fractions. These numbers have to be integers, and then also a cannot be negative. Okay, so let's see how we can change this equation so that it follows those rules. So to get rid of the 2 in the denominator, I'm going to multiply both sides of the equation by 2. So if you do that, 2 times negative 1/2 is negative 1. You have to distribute that to both, so you'll get 2y equals 3. 3/2 times 2 is 3. Okay, and now we just need to deal with that negative. So a couple of things you could do here. First of all, you could have multiplied by a negative 2 on both sides and distributed that. A negative times a negative is a positive, so you would have a positive x there. Another option is to just go through the equation and change every sign, right? Because if I multiply the whole equation by negative 1, that would just change every single sign that you see. Okay, so that would make the equation x minus 2y equals negative 3. Okay, so that's your final equation. All right, let's look at one more. So this one is going to go through the point 1/4 negative 2, x1, y1, and the slope is negative 6. We want this one again to be in standard form. So y minus negative 2 equals negative 6 times x minus 1/4. All right, distribute the negative 6. Okay, I'm going to move this 6x to the other side and subtract the 2. So I get 6x plus y equals, and then 3/2 minus 2 gives me negative 3/2. Oops, not negative 3/2. Negative 1/2, so negative 1/2. Okay, almost done. Just remember you can't have any fractions, so we need to multiply this entire equation by 2 to get rid of that 2 in the denominator. So that's going to be 12x plus 2y equals negative 1. All right, and now let's look at a few graphs. So let's go over graphing equations. First, plot the y-intercept. So we're going to plot that at 6. And then use your slope to get to the next point. So the slope here is -2/1. So you're going to go down 2 and over 1, down 2 and over 1. So those are all points on the line. So now you can draw your line through those points. Okay, a little crooked, but we get the gist. But how do you graph a line that says y equals -3? What you do here, if you have an equation like on 19 or 20, where it's just y equals a number or x equals a number, is you're going to find the points on the graph where y equals -3. And you're going to graph every single point where y equals -3. So here's y equals -3 and x equals 0. Here's another point where y equals -3, and here, and here, and here. All the points on this line. So the line y equals -3 is this horizontal line. Okay, so every time you graph a line that's y equals, it's going to end up being horizontal. Now what about x equals? Let's find every single point where x equals -3. Here's one point where x equals -3. And another, and another. All of these points, x equals -3. So that's going to end up being the vertical line going through x equals -3. So with those equations, you're literally getting the line that goes through every single point where x or y equals that value. All right, so now let's do some investigation on the next page. Choose 2 points from the line graphed in number 7. Use those points to calculate the slope using the slope formula. So I want you to try this on your own, so pause the video and then check back to see if you're correct. So you're calculating the slope for the line graphed in number 7 and number 8 using the slope formula. Alright, so let's look at this together. So on number 7, I'm just going to go back over here to number 7. Oh, I changed the numbers, I'm sorry. I should have said 19 and 20. So on number 19, just taking 2 points on this line. Let's say I use 2, -3, and 6, -3. Okay, so remember those points, 2, -3, and 6, -3. Those are 2 points on my line. So 2, -3, 6, -3. Now I'm going to plug those into the slope formula. So m equals -3 minus -3 over 6 minus 2. That's 0 over 4. And anything, 0 divided by anything is going to be 0. So the slope there literally comes out to 0, which I'm sure that you had to memorize in Algebra 2, that the slope of a horizontal line is 0. But now you see that if you actually tried to calculate it using any 2 points on the line, you literally get 0. Let's do the same thing for number 19, I can't remember, not number 8. Let's see, number 20. Okay, so pick any 2 points on this line. I'm going to do -3, 0 and -3, 5. -3, 0 and -3, 5. So the slope here is going to be 5 minus 0 over -3 minus -3. So 5 over 0. We cannot divide by 0. So anytime you do divide by, or attempt to divide by 0, we're going to call that undefined. So that's why you've been told in the past that a vertical line has a undefined slope. And that is why, because if you try to calculate the slope, you're going to be dividing by 0, and we can't divide by 0. Therefore, the slope is undefined. Okay, so just to kind of recap that, if you have a horizontal line, the slope is always going to be 0. And if you have a vertical line, the slope will always be undefined. And even if you try to calculate the slopes using the slope formula, you will get those slopes. All right, now let's talk about parallel and perpendicular lines. Parallel lines are two lines that have the same slope. Perpendicular lines are lines whose slopes are opposite, reciprocals. And what do those words mean? So opposite, we're just saying to change the sign. And reciprocal is when you flip the fraction. All right, so let's look at 21 and 22. Find the slope of a line parallel and perpendicular to each equation. Parallel, same slope, so 1/2. Perpendicular, opposite reciprocal, so flip it. That's going to become 2 over 1, or just 2. And change the sign, so -2. All right, number 22. Parallel, -4. The slope would be -4. Perpendicular, flip it, 1 over 4, and change the sign. Oops, sorry, it was already negative. So now it becomes positive 1 over 4. 23, determine whether the following lines are parallel or perpendicular. So for this, I would recommend solving for y to get in y equals mx plus b, slope-intercept form, so that you can see the two slopes and determine if the lines are parallel or perpendicular. So for this first one, I'm going to solve for y by dividing by -3. Okay, so the slope on the first one is -3. Do the second one. Add the 2x. Divide by 6. Okay, I went ahead and reduced that fraction. My slope came out to 1/3. Okay, because those two slopes are opposite reciprocals, these two lines are perpendicular. Okay, so you are solving each one for y so that you get y equals mx plus b, and then you can compare the slopes. And our last question for 2.2. Find the equation of the line parallel to this line and passing through this point. Okay, so if our line is parallel to this equation, to this line, then that means they have the same slope. So what we can do is solve this one for y so that it's y equals mx plus b, and that will tell us our slope. So I'm going to subtract 5x and the 4, move those to the other side. So -3y equals -5x minus 4. Divide by -3. So those two negatives, the -4 divided by -3 becomes positive 4/3. Okay, so it looks like our slope is 5/3. Okay, and we're going to pass through this point. So that'll be our x1, y1. So we will do y minus y1 equals 5/3 x minus x1, so plus 4. They didn't tell us which form to put this in, so I'm just going to leave it like that. That is a perfectly good way to write a linear equation in point-slope form. Alright, so that concludes 2.2.